Hi, welcome to Module 5. We'll be looking at counting rules and Bayes' theorem in this module. We'll start with looking at counting rules, combinations and permutations, before which we would like to understand factorials, the arrangement of elements and the possible combinations of various elements. The fundamental rule of counting is if an event can happen in n1 different ways and another event b can happen in n2 different ways, then the ways in which both of them can happen is n1 times n2 ways. In general, if there are m events, then there are n1, n2, n3, n4, nm ways of finding the events happen. So factorials is another way by which we understand how n items can be arranged in a particular order, and that's called as the n factorial. It's a product of all integers from 1 to n. So n factorial is n into n minus 1 into n minus 2 into till n minus 1. That's 1. Factorials are basically useful for counting the possible ways in which arrangements can be done. So there are n ways you can choose the first element, n minus 1 ways you can choose the second element, and so on. To understand that in a better way, the first item can be chosen in n ways. Let's say there are 10. The first item can be chosen in 10 different ways. The second item, the first item being chosen already, can be chosen in only 9 different ways, n minus 1. And the nth item would be chosen in only one way, the last option that's left. Here's a small example. So how many ways can you order 3 letters A, B, and C? There are 3 choices for the first letter, 2 for the second, and 1 for the last. So there are 3 into 2 into 1, 6 different possible ways to order the letters. So if you have to order 6 letters, it becomes 6 into 5 into 4 into 3 into 2 into 1, 720 different ways. A small note, by definition, 1 factorial is equal to 1 and 0 factorial is equal to 1 as well. It's denoted by n factorial. Small example. Let's say a home appliance truck must make 3 different stops in 3 different centers, A, B, and C. Now, in how many different ways can the 3 stops be arranged? So there are 3 into 2 into 1, 6 different ways. So let's try to list the possible arrangements. There would be A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. If there are about 9 players in a baseball match, and now what are the different ways in which the batting order can be defined for rotation? That would be 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. That's about 362,880 different possible ways. Please note here, the baseball players are arranged in an order for the batting sequence. A small example. So how many unique stock keeping unit labels can we make in a hardware store? Supposing you are using an alphanumeric, that's alphabets and the numbers. So you're going to use 2 alphabets to begin with and use about 10 numbers, 0 through 9. So it would look something like AF1078 or RT4855, LL3319. So that are 2 alphabets and 4 numbers. It would be like filling up 6 different boxes, 2 alphabets, 26 each possible ways, 4 different boxes in 10 different possible ways, 0 to 9. So there are 26 ways to fill first and second box, 10 different ways to fill third and sixth box. So that's 26 times 26 times 10 times 10 times 10 times 10. So you can see the number. That's about over 6 million different unique labels that can be generated. So these are some of the applications that are normally used for counting rules in real life. Let's just check if we understood. That's a men's cotton shirt jamboree, and they come with 6 different colors and 5 different sizes and 2 different styles. Now, what would be the minimum number of shirts of different types that the organization could probably have? So it would be 6 times 5 times 2, 60 possible shirts. But the number of each type of shirt to be stocked depends on the demand as well. But the shop, if it needs to stock one shirt of a kind, then it would be stocking 60 different shirts. That's the understanding of this particular counting rule. Because here the order is not looked at. The numbers are looked. So there's a difference between the ordering arrangement and the total numbers. Permutation. Permutation is an arrangement in a particular order of randomly sampled items or of a group of items. It's normally denoted by NPR, N permutation R. The way in which the number of permutations to be calculated is n factorial over n minus r factorial, where n is the total number of items and r is the number of items that are being sampled. In other words, how many ways can r items be arranged, treating each one as a different arrangement? Let's say you have three alphabets x, y, z, then x, y, z is different from z, y, x. Although they contain the same three letters, the orders are different. So they form a different combination. If I have to choose three letters out of six letters, A, B, C, D, E, F, so I will choose the first letter in 6 different ways, 5 different ways for the second letter, 4 different ways for the third letter. That makes 6 times 5 times 4, 120 possible orders or different orderings, or also called as permutation. Applying the formula, that would be 6 factorial by 6 minus 3 factorial, 120. In this case, the order is important, indicating similar collection of elements in different orders mean a different element. So let's say, for example, A, B, C is not same as B, C, A. The other type is combination, in which case R items are chosen from N total items and the order of selection is not important, indicating X, Y, Z is same as Z, Y, X because they are the same three elements. So they do not make a different element. So combination is denoted by NCR, N combination R, normally used in binomial applications. The way in which you calculate NCR is n factorial over r factorial times n minus r factorial. Small example. Suppose I have to pick 3 letters out of 6 letters as we saw in permutation example. So if we choose B, C, and D, so BCD or BDC or CBD or CDB or DBC or DCB, there are different ways these combinations can be ordered, but they all mean the same because they are the same 3 letters B, C, and D. So how many such combinations of these letters are possible? You can only have 20 combinations. Let's look at another example to understand combinations. There's a home appliance customers waiting for service. Name them A, B, C, D, E, 5 of them. But the technician can service only 3 of them before lunch break. Now order is important, so each arrangement of the 3 is different. So the number of possible permutations is 60 different permutations, 5 factorial by 5 minus 3 factorial. An understanding of the same example. Now the 10 distinct groups of 3 customers, ABC, ABD, ABE, etc. And now each of these can be arranged in 6 different forms. So totaling to 60 different permutations. The same example, in case you do not give importance to the order of elements, meaning ABC is same as BCA, etc. Now the same event would contain the same 3 customers and hence they cannot be a different element. The number of possible combinations is only 10. So combinations are always less than permutations, since order does not matter in combinations. So 10 combinations is much smaller than 60 permutations, as we have seen in the examples of the service calls. Combinations are more easily enumerated because ABC, ABD, etc. So when do you use combinations? When do you use permutations? Both of them calculate the number of ways you can choose R elements from n items. But in permutation, the order is very important, while in combinations, the order does not matter. And the permutations are normally more than the combinations. Thank you for watching. Get to the next module.